Hi, did you know EDEXCEL made practice papers? Well, they do, and they're a fantastic resource. They are full sets, papers 1, 2, and 3, and 80 marks on each. So, how many have they actually made? Loads. I mean, loads. There are 144. I don't think anybody would need that many. Anyway, I am making it my mission to do worked solutions for as many as I can. Obviously, the goal is all 144. I do work full time though, so I'm going to be creating them and pushing them out as quickly as I can. So watch the channel because new videos are going to land all the time. Now, to use the papers, I would recommend downloading them, sitting quietly, cracking on with it, and then coming back to do the marking. You've got all the solutions with walkthrough examples. So if anything's gone wrong and you need to see the steps in the methods, it's all going to be there for you. Now, for grade boundaries on the end screen, I've provided some percentages as guide only. No one knows what the grade boundaries will be ever. Anyone telling you are really just trying to give you a guide, and mine is no different. I have gone for the highest percentages we've seen so that we are reducing our risks, but it gives you a goal. It gives you something to head for. And I think that is really, really useful. So once you've got your score, check out the end screen, and that will also give you an idea of your grade. Now, if you're really struggling, if you're finding that you're sitting down to do the papers and they're not going very well, but you like the way that I explain and walk through the questions, then I do have some courses that are available. They are in the description below, so you can just click on that link. If you are somebody that wants to be studying and gaining the higher grades, my grade 6 course is currently free here on the channel. So do go and check that out. The course is designed to help you develop your critical thinking skills. So whilst it's all labeled up as grade 6, because we use a lot of those topics to help us, actually what you're going to really get from that is those topics, but the critical skills that you need. Okay, well, good luck with your studies. This will make a great addition to your revision. If you like what we're doing, please hit that like and subscribe button. That'll hopefully push the video out to more people and more people can benefit from it. Obviously, comments are great. So yeah, just good luck. Revising for a GCSE maths, it's going to be tough. So I wish you well. Okay, so we've got another crossover question. So the diagram shows the cross section of a solid prism. Now, when we're reading that word prism, we should be realizing that what we're actually looking at is a 3D shape. They just haven't drawn a 3D shape. They've just done the cross section, which would be the front face. The length of the prism is 2 meters. Now, again, if we look at the diagram we've been given, all the edges on the cross section are in centimeters. So we really kind of need to clock that as quickly as possible. I'm going to draw on that length just so I can visually see it, and I can then be mindful of my shape because I can see the whole shape. And of course, this edge here is 200 centimeters. I want to stay in the same unit, so I'm converting my 2 meters to 200 centimeters. So just in those first 2 lines, I've been able to glean all that information and get it added into that diagram. The prism is made from metal. The density of the metal is 8 grams per centimeter cubed. I've got to work out the mass. Now, those are those key words that I want to be picking up on. And we've got our formula triangle, mass, density, volume to help us. The density has been given to us. So we've got that. We have to work out the mass. We can't do that unless we have the volume. And the volume has not been given to us. We know that the units of the volume have got to be centimeters cubed because they're telling us that in the units of the density. So having changed into my centimeters, I've already kind of set that up in motion. And now I've really just got to work out the volume. So we're going to split this cross section, and we're going to work out the area of the cross section. So we've got this section here, which is 7 by 2. And then we've got this section, which if this bit here is 2, then that's going to be 5. So it's going to be 5 times 2, which is 10. So my cross section is 24. I'm going to times that through by the length, which is 200. That's going to give me 4,800. That's my volume. Mass is density times volume. So I've now got to do 8 times 4,800. Again, it's really down to you. When I'm multiplying by one digit, I tend to just break the whole thing up. So I would say I've got 4,000 times 8, and I would say I've got 800 times 8. So 4 8s are 32, and then I've got those 3 zeros. 8 8s are 64, and I've got 2 zeros. Just be careful when it comes to lining that up. And my final answer is 38,400. Now, if you look at the dotted line, and I'll just pop down there so that you can see, if you've not got the paper in front of you, there are no units. So it's absolutely essential that we include the units or we're going to lose a mark. The units are with the density here. And I'll explain how that works in case you're not sure how I just know this, okay? So I know it's grams, and that's my final answer. Now, if I go back to my formula triangle where I've got mass, density, and volume, mass is grams, volume, that looks like a Y, is centimeters cubed, and the density is these two on top of each other, grams over centimeters. It's a bit like miles per hours. Your speed is your distance over time. That's your units. Hope that gave some clarification. We've got a crossover question here. Dylan is driving from London to Newcastle. He will drive a total distance of 240 miles. He's leaving at 9:30. And then we're given some information about that journey. So what we're going to do is we're going to build a picture of this before we do anything else. So I know that it's London to Newcastle. I know he's leaving at 9:30. It's a total distance of 240 miles. So I'll get that marked on. And it takes an hour and a half to do the first 90. So I'm going to say that in this section of my journey, the distance is 90 and the time is 1.5. I've changed that 1.5 into decimals. I also know the distance here. 240 take away 90 is 150. So I can add that into my diagram as well, because I do know that. Now we've got to use this information to estimate the time Dylan will arrive in Newcastle. Now, in order to work out the time, we're going to need the speed and the distance. Okay, these are our keywords, and we've got this formula triangle to help us. I'm going to need the total distance and the speed. So in the first part of the journey, the speed can be found because we've got both D and T. So 90 divided by 1.5. Now I can go into bus shelter, or I can actually think about this. If I've got 90 minutes taking 1.5 hours, if I divide this through by 3, that will give me 30 minutes. And if I was to divide this through by 3, it would give me half an hour. I've got 3 half hours in an hour and a half. So I can then see that it's 60 minutes in 1 hour. And that may be a better way than going straight into your bus shelter. But of course, your bus stop's going to work as well. So it's just a couple of ideas really of how you can get to your speed of 60 miles per hour in that section of the journey. Now, we are assuming he's driving at the same speed throughout his entire journey. Now we know that the speed is 60. I can work out the time it's going to take to travel that distance of 150. So we've got 150 over 60, distance over time. Sorry, distance over speed. Divide through by 10. I can then divide through by 3 to cancel this down a little bit. 3s into 15 go 5. 3s into 6 go 2. How many 2s can I get into 5? 2 with 1 left over. So that second part of the journey is going to take 2.5 hours. The first part took 1.5 hours. If I add those, I've got a total time of 4 hours. So you add your 40 and 9:30, so 10, 11, 12, that'll be 1:30, and that is your final answer. We have to write down an assumption that we made, and we assumed the speed was the same throughout, and that's what we would write down. Another factor that we could have considered and written down to get that mark is that I assumed there would be no stops along the way. That would be an acceptable answer as well. Okay, so we've got a car that's being bought for 4,000. It's depreciating by 10% each year, and we have to work out the value of the car. Now, if you're one of my students, I will have drummed it into you to do a 2-tick test, which this passes because this is a decrease, and we would be doing original times multiplier equals result. We have a period of time, so the multiplier has that time attached to it as a power. But this really is a calculator method, and we need to remember that. It would work, but we'd be doing a lot of maths by hand. So we really need to think about our non-calc methods. It's depreciating by 10%. Now, if I find 10%, all I have to do is divide by 10. So it's very straightforward to get started on this without overcomplicating it. So it's going to lose £400 in its first year. So 4,000 take away 400 is 3,600. However, we don't use 400 again because the value of the car is now 3,600. In the second year, it's going to be 10% of that. So dividing that through by 10, we've got 360, and that's what we're going to take off. So we'll just reduce that, carry that across, gives us 4, 2, and 3. So our final answer is 3,240. Okay, question 4. We have got wallpaper remover, 600 millilitres, and you mix a quarter of the remover with 4,500 millilitres of water. So that's our fact. Suha is going to use 750 millilitres of water, so actually quite a lot less, and we need to work out how much wallpaper remover she's going to need. So let's start off with the information in the box. Only a quarter of the remover is used with the water, so that's our first step. We're going to find a quarter of 600. You can just half it again. And then we're going to set that fact up. We know that 150 is mixed with 4,500. Put that in side by side. This is my boxes in label grid method. So again, if you've seen any of my videos, you'll know I love setting fact questions up like that, where the fact is here side by side. Now, in the question, we're going to use 750 millilitres of water. Well, this is my water column. So 750 will go in here. Now, what I need to do when I've got a calculator is just multiply across and divide. But obviously, we've got a non-calculator paper. So I want to set this up in the easiest possible way for myself. I know I have to divide by this one in the corner. So whether I like it or not, that is going to be on the bottom of my fraction. And now I've got to choose between the other two, and it really doesn't matter. I know 15, just looking at it, will go into 45. So it makes really good sense for me to pop that one on top and then start cancelling. I know that that can be divided through by 10. I can then divide through by 15, which would give me 1 at the top. 15s into 45 go 3, and then the 0 joins it. So I've got a 30th. Now I can do the times. So I've got a 30th times by 750, which looks like it's going to be really tricky, but it's not. Just pop it over. If this was fractions, you'd just do it. You'd have 750 on the top and 30 on the bottom. And now I can divide through by the 10. And 3's into 75, go 25. So really it's just having confidence with that multiplying and dividing by hand. Okay, another crossover question. There are 18 packets of sweets and 12 boxes of sweets in a carton. The mean number of sweets in all the 30 packets and boxes is 14. And then we've got more information about the mean on just the packets. And we want to work out the mean in the boxes. So we got to break this down line by line. We know that the mean is add them all up and divide by how many are there. So the meaning of the word mean doesn't change. This context is very different now because we don't have a list of numbers to add. What we do know, however, in this first line is that the mean of all 30, so that's how many are there, is 14. So there's this total that got added together, and when it got divided by 30, it gave a result of 14. What that enables me to do is to get the total. If I just bring that 30 across and multiply by it, so 3 14s are 42, add the 0, then although I don't know all the individual numbers, what I do know is that all 30 of them will add to that. And then I'm going to do the exact same thing with the mean for the packets. So I know that there is a total of 18 packets that when it's added together, there's this value. I don't know what it is, but there's this total. But if I was to divide it by the 18, it would equal this mean of 10. And again, if I just multiply that through, I can see that the total for the packets is 180. Having these two totals is going to help me with getting the mean for the sweets. Because again, I'm going to need the total of the sweets to divide by how many sweets there are. Well, I do know that number. It's 12. That's in the first line. That's going to equal the mean, which is what they want me to find. So this bit here needs to be found using what we've got so far. And we've got the total of everything together, and we've got the packets here. So 420, take away the 180, is going to leave us the boxes. So that would be 0, that would be 4, that would be 2. So it's 240. So we're doing 240 divided by 12, which is really nice and straightforward. 12 into 24 go 2, add on the 0. So our mean is 20. Okay, another crossover question. We need to write these numbers in order of size. Now, to do that, I'm going to express them all as ordinary numbers, first of all. So the first one, if I am going to be timesing through by 10 to the 2, it's the same as timesing by 100, or moving that decimal point 2 places, which would give me 3.8 as an ordinary number. Timesing by 10 to the minus 2, remember, a negative power is going to make it smaller by 4 movements. 1, 2, 3, 4. This is 0.3800, or just 0.38. You can add them in or not, entirely up to you. I probably wouldn't normally. And then we've got a negative 1, so just one place will give us that ordinary number. Once I've got the ordinary numbers, it's easy for me to then start seeing them and comparing them. So 0.0038 is the smallest. So I would be writing that one down first. This is the next smallest, and finally 380 on the end. And notice I'm using the numbers that were originally given to me when I do rewrite them. Okay, we need to work out the value of n. So we're just going to follow through the problem using our indice rules. So the top would tidy up to 2 over 9. We add the powers when it's a multiply. And then that gives us this. But we know the result will be 2 to the power of 5. The divide rule means you take the powers. So 9 take something is 5. Our n must be 4. Okay, to write down all the possible values of y, we really want y on its own. And at the moment, it has 2 multiplied to it. So we're going to solve that by just dividing through by 2. And that means dividing everything through. So we'll end up with minus 3, y, which is what we want, and 2.5. Now we're being told y is an integer, which means whole number. So the list of possibles are minus 3, minus 2, minus 1, 0, 1, 2. And then you check in with your signs. This sign does not have an equals attached to it. Y is less than 2.5. We want to write down the greatest possible values of y. 2 can count in this case because we are below what it needs to be, even though it doesn't have the equals. So I hope I've explained that well enough. And then we've got our equals, which means our minus 3 can be kept. So that is our final list. Question 9 requires actually quite a lot of problem solving. It feels like it shouldn't be as much work as it is, but I don't think there are any shortcuts here. We've got these two numbers and each are greater than 3. The highest common factor of x and y is 3 and the lowest common multiple is 36. So I'm first of all going to be thinking about these factors of 3. The number 6 has a factor of 3. So does 9 and 12 and so on. I want to consider which ones of those also have multiples of 36. Well, that certainly does, that does, and that does, but 21 doesn't. So I can stop here. Now I need to consider the multiples of these numbers. My 6s, my 9s. I've got 12, 24, 36. And I've got 18 and 36. The lowest common multiple is 36, and we can see that they've all got 36, but we can start eliminating. So the 12 and the 6 also have 24 and 12 in common. So 36 isn't the lowest common multiple. So they will not be the pair. If we consider factors, 18 and 12 are in the 6 times tables, so 3 won't be the lowest common factor there. So that brings 9 into being a must-have as a solution. So we've got 9 with their factors, and now we want to pair it up with one that doesn't sort of spoil what we've got set up, and 12 will do that beautifully. And it may be, if you can't see what's happening with the numbers, that you just show all those factors and all those multiples so that you can then make that pairing. And I can see that they both have the multiples of 36 from my lists here, and they both have that lowest common 3. So my numbers are 9 and 12. Okay, so we've got to enlarge the triangle by a scale factor of half, which means it's just going to be half the size it currently is, using center 2, 0. So 2, 0 is here. Now, for me, I am a massive fan of using vectors for enlargements. So what I'm going to do is work out the vector from my center to the right angle of my triangle, to this corner here. And I would go 2 forward and 4 up. So the vector is 2, 4. And then I would times it through by the scale factor. So if I half those numbers, I will end up with 1, 2. So I'll do that movement, which takes me here. That is the corner of the new shape, which has to be half the size. So it will be 2 up instead of 4 up, 1 along, and then you join it up to make your triangle. So we're being asked to draw a histogram for the information in the table. Now that is my key word, and it needs to trigger really important frequency density, and class width. So we've got this formula triangle, just being a bit lazy and not doing the edge of the triangle. That helps me. It's like a dominoes effect. I read this, it triggers this, and now I've got a load of formulas to help me. frequency divided by class width will give me frequency density, or frequency density times the class width would give me frequency. So now I've got these formulas that I can use with these numbers to help me draw my histogram. Now, I need to know that this scale here is my frequency density, and this scale here is my speed. I can see that the speed is labeled, so the speed is my class width. To get the frequency density, I do, and we can see it here, frequency divided by class width. So the first one would be 15 divided by 5, giving me 3. And I'm going to repeat that on all the rows. Now I know the heights of my bars when I draw them. I just need to create my scale here. And it's going to be very straightforward, actually. The hardest thing is the paper because it hasn't printed very well. So that's 5, 4, 3, 2. And my 1, which is really hard to see, is, I think, here. Now, one of the things that I like to do is just mark on my class widths so that I am really clear. And I'm just going to zoom in now to make this a little bit easier. So I'm going to be drawing a bar from 60 to 65. So 1, 2, 3, 4 here. And then 65 to 70, which would be here. 70 to 80, that's the width of my next one. And then 80 to 100. And I just find by having those dashes in place, it's just one less thing to think about when I start drawing the bars. You can label your axes. And my first one goes in. And then I'm just going to draw the rest of them. And we're done. So that's part A completed. We've drawn the histogram. Now we have to work out an estimate for the number of cars with a speed of more than 85. 85 to 100 is a range of 15. If I mark off my 85, we know the class width is 15. We know the height is 1.2 from part A. And the frequency is the area of the graph. Or you can use your formula triangle. Frequency is the class width, which is 15, times by the frequency density. And we get a final answer of 18. Okay, to simplify, we're going to factorize. So the first one, do our working out down here. We do our brackets, drop our x, do our signs, and it's 4. So 1 and 4 multiplies to make the 4 and will help me make the 3. So it will be 4 take away 1. And that is what we have on the top. Now we're going to do the same with the bottom one. So I'm not going to rewrite this one. Just going to do my brackets. I drop my 2x. I do my signs. It starts neg. So I switch the second. And if you haven't seen this method and you like this method, I've put in a link just coming onto the screen now that takes you through to a video that really explains this clearly. It's a great little method and it takes a lot of the worry about the signs away. I mean, it doesn't completely take it away, but it does help massively. So I've dropped the 2x, I've dropped the signs. I have to multiply the first and the last to give me 6. And it's the factors of 6 that I'm going to be working on. I want to make a 5, so 2 and 3 and 6 and 1 could make me that 5. So I really need to think about it. To make a 5 out of 6 and 1, I'd have to have positive 6, take away 1. But I don't have any positives, so it will be this one. Negative 2, and then take away another 3 will take me to negative 5. Now, we did this multiply step here to make the 6. So there's always a divide step to tidy it up. Here we're going to divide by 2 because they're both in the 2 times table, which will give me x minus 1. And this bracket won't divide down. The second bracket does sometimes, but not always. So now I can rewrite my factorized version. And I'm going to write the 2x minus 3 first because I can see my match is the x minus 1. They would cancel out, and my final answer is what we have left. So part B, we have to write as a single fraction. Now, if we look at this, it's an addition. And when we add fractions, the denominators have to be the same. And our denominators are not the same. So I am going to be multiplying the first fraction through by x minus 2. And that will give us the first fraction. And then the second fraction will multiply by x plus 2. So we've cross-multiplied just like we would if it was normal fractions. Now, I am going to concentrate on my numerator. So I'm really just thinking about this here. I'm going to be expanding those. So I've got 4x minus 8 plus 3x plus 6. That tidied up completely to 7x minus 2. And the bottom, even though the brackets are the other way round, they are identical, and I can just bring that underneath. And we are done. So we've been given a hemisphere with a radius of 5 centimeters, and we're being asked to find the total surface area. We've got the surface area of a sphere. We can see that this is half a sphere. So we're going to be using 4 pi r squared, and we must remember to half it. So this is going to give us 4 times pi times 5 squared. 5 squared is 25, times 4 is 100. So we have 100 pi, half that, and we've got 50 pi. And when we're being asked to leave an answer in terms of pi, it really does just mean leave pi in the answer. Now, this is the curved surface only. If we're going to find the total surface area, I'm going to need to find this part of the surface as well, which is a circle. So we're going to need to add on pi r squared. So we've got pi times 5 squared, which is 25 pi. So add these two, and you get your answer of 75 pi. So we've got 20 counters in a bag, 8 yellow, 12 green. 2 counters are taken at random, and we've got to work out the probability that the 2 counters are different colors. So this is your sort of classic probability tree diagram question. So our first pick, which is either going to give a yellow or a green, of course, is 8 out of 20 and 12 out of 20. Now the second pick, again, where we get the 2 possible outcomes, are going to be slightly different fractions. If I've gone in this direction, I've already taken a yellow. That means that there are only 7 yellows left out of 19. And of course, I've got all the greens. Now, when I do the second one, I don't try and work out the yellows. I don't kind of do this in order. I think about it as in a green has gone. So if I had 12, I now only have 11 left out of 19. I find it much easier to go with the same colours and then finish it off from there. Now, my 2 pathways could be yellow followed by green, or green followed by yellow. If I do the yellow and green pathway, I pick up the fractions 8 over 20 and 12 over 19. I just need to multiply these. That's going to give me 96 over 380. Now, this is within our times table grid. This really is 2 times 19, which is 38, and then add your 0. So it's not tricky maths to do without your calculator. And then our second pathway was green, 12 20ths times our yellow. And it really is just the other way around, isn't it? It's the same maths. When you get 2 outcomes, you don't have 2 answers. It just means you've got a little bit more to do. We add our answers. So we're going to do 96 plus 96. I've got 12. Carry the 1. I've got 192 over 380. Okay, so they're telling us that n is an integer greater than 1, and we've got to use algebra. Now, that's really important to spot. What I see a lot of students do is substitute numbers in, and by doing that, you will get even results. And they feel that that is some way to prove or show that this would always be even, but you're not doing it algebraically. So it actually doesn't get you any marks. So doing it algebraically means we're going to start here
where we've got n minus 1 all squared. That can be written as n minus 1 times n minus 1. So if I crab's claw or FOIL, whatever the method is that you use for expanding brackets, you will end up with n squared minus 2n plus 1. We've also got n squared minus 1 in the first bracket, which is going to get added. This then tidies up to 2n squared minus 2n, and my minus 1 plus 1 is cancelled out. Now, I don't like to just leave it there. I like to then give some additional explanations as to why this works. And I would seriously encourage this when it comes to a proof question. It doesn't matter what n is. Once it's multiplied by 2, it will be an even number. So this, no matter what n is, will become a multiple of 2, which is even. This, I might put an arrow to that as well. This is also a multiple of 2. Now, an even taken even will always equal even. So I've covered all my bases and I've really explained it. I've done the algebra, I've explained the algebra, and wherever possible, I would encourage you to do that, as I said, on a proof question. Okay, so for question 16, we're being asked to show that the triangle ADC is congruent to ADB. Now, congruent means exactly the same. So if you were to cut them out and stick them on top of each other, they would fit beautifully. Now, the information that we've been given to help us is that we are looking at an equilateral triangle. D lies on BC and AD is perpendicular to BC. Now, because this is an equilateral triangle, the first thing that I can note is that AD is a shared edge. So I know that whatever size that is, and I don't know how long it is, but whatever length it is, it's the same for both triangles because it's shared. I also know that because it's equilateral, that these edges are going to be the same as well. Now, this will be a perpendicular bisector. The reason for that is because, again, it's equilateral. So the tallest point of this triangle dropping down is going to hit it exactly in its midpoint. That tells me that these edges will also be equal. So I've got each side matching, and I can use the side proof that it is congruent. All I really want to do now is just get that all written down so it's super clear and easy for my examiner to follow my train of thinking with all of that. Now, it's not the only way to do it, so it's really important that you don't feel you may have gone wrong. There's an argument for SAS, where you've got side angle side, and there's also an argument for ASA. So if you came up with a good argument for those two, it would work, because obviously we know these angles. If it's an equilateral triangle, I know that's 60. That's bisected, so I know that these are 30. And that's 60 and so on. So you can have worked your way around in a completely different way. I've got to prove that BD is half AB. So let's draw this out. That's my BD, and that is half the base. But I've got to prove it. Now, because of the way that we approached the original part A of the question, have already showed that we know that BD is equal to BC because they are congruent. And we've gone through the proof of that above, so I don't need to do any more than that. We know that we had an equilateral triangle, which also helps explain because our edges were all equal, so it had to be half. So therefore, BD is equal to a half AB. Now, interestingly, you could have used exact trig ratios. You could have gone down a completely different route, not used the congruence in part A to help you explain part B. And you could have used your trig ratio. Cos 60, the exact trig value for that is a half, and that would have gone on to help you explain what was going on there. But yeah, it's an interesting question, that one, and it could have been taken in different ways, or approached in different ways, I should say. Okay, so rationalizing the denominator really just means multiply out that third. It's a fraction, so to keep it equivalent, I do the same to the top and bottom, which is going to result in 6 root 5. And then root 5 times root 5 cancels the root and just leaves us with that 5. Expand and simplify. So we're going to apply our crab's claw, foil, etc., whatever our method is, to this. However, I would really encourage you to take a good look at your surds to see if there's anything that you can simplify. If you simplify earlier rather than later, then you're going to be working in lower numbers. They're just much easier to manage. Now, 10 isn't going to cancel down and simplify. There's no square number factor, but there is a square number factor with the 20. Root 20 can be broken into root 4 times root 5, which is 2 root 5. So instead of using root 20, I can use 2 root 5. Now, when I crab's claw this, I will end up with 2 root 5 plus 4 root 5 plus root 50 plus 2 root 50. Now, my root 5s can be collected for 6 root 5, and my root 50s can be collected for 3 root 50. And obviously these are added. So that is an answer, but it's not fully simplified because this third will cancel further. I can break this up into root 25 root 2. And obviously the root 25 will turn into 5. My whole numbers get multiplied to create 15. So the whole thing tidies up to 6 root 5 plus 15 root 2. Okay, so part A of this question is asking us to construct the graph of x squared plus y squared equals 9. We should recognize this as our circle equation. So we're going to be drawing a circle around the origin. So the center is the origin. And our 9 from the circle equation is r squared. Now we want the radius. So we're going to do the square root of 9, which will give us 3. So what we'll do is stab our compass at the origin, stretch the second, or the pencil leg, if you like, out to the 3, so that we can then stab the pencils at 3, and we can just sweep it round, and we can create that perfect circle. Okay, so by drawing the line x plus y equals 1, we need to solve these equations. And it's really important that we're using the graph and not trying to do it using the algebra this creates, because that's not what they're asking. So we've got x plus y equals 1. So when x is 0, y would have to be 1 to equal 1. So that gives us the coordinate 0, 1. And then obviously the opposite would happen as well. Now you can either keep going and working them out, or you can see that the pattern here is along 1, down 1, along 1, down 1, and you can plot the rest of those coordinates. And then you draw your line on. Now, where they cross is the result that we're looking for. So let's just zoom in here and see where they cross. So we've got minus 1.6, 2.5. And pop that straight on. Then we look at the other one. So we've got 2.5, 2.6. I'm going to go, because the other one was 2.5, I'm going to go with 2.5 because it looks from my drawing to be somewhere in the middle. But that other one for the y-axis is definitely minus 1.6. So I'm going to see, because these have switched, I'm going to say these have switched and put that down as my answer, which is the correct answer. There is a tolerance of a plus or minus decimal place. So if I had thought, oh, I think it's 2.6, it wouldn't have been a problem. I would have still got the mark. Okay, so P is inversely proportional to V. So we'll set this up immediately with our constant of proportionality. P is equal to K, and because it's inverse, it will be divided by V. I'm then going to pop in the information that they've given me. So P is 5, K over V 8. And then that will just go land as times, and we'll work out that K is equal to 40. So our formula is P equals 40 over V. Calculate the value of P when V is 2. So P is equal to 40 divided by 2, which is 20. So a really nice, straightforward proportion question there. Okay, so we've been given a diagram of a graph, and the graph is being called f of x. So we don't know the detail, we just know that it's f of x. We are being told that the turning point, or the minimum point, is 3 minus 4. And then we've got to write down the coordinates of that minimum point when it's been transformed. So by taking the function of x and adding something to it, taking inside the bracket, outside the bracket, just with an additional component to it, we are in the topic of transformation of graphs. Now, if the addition is away from the x, which this is, then it will be my y coordinate that is affected. So the minimum is 3 minus 4. The y coordinate is the coordinate that's going to be affected. We will be adding 3, doing exactly what it says. And that will give us a final answer of 3 minus 1. And basically what's happened is a vertical translation where this entire graph has just moved up 3 places. The next one has the addition in with the x. When it's in with the x, then it's the x coordinate that's affected. So I've got the original 3 minus 4. This time it's going to be the x coordinate, but we don't add 2. We do the opposite when it's the x-axis. So instead of going forward 2 places, I will be going back 2 places. And when I take off the 2, I will be at 1. So 1 minus 4 would be the coordinate of the minimum when a horizontal translation has taken place. I'm just going to put the brackets on that. Really important we keep our brackets. Now, the last one, we are in with the x again. This actually performs a reflection in the y-axis, but we can just be thinking about the coordinate itself. We currently have 3 minus 4, and I am timesing the x by minus 1. So when I times this through by minus 1, it will give me minus 3 minus 4 as my final answer. But I think the key with this is to really try and remember that this does create a reflection. Okay, our last question. We've been given 3 points as coordinates, and we've got to find an equation of the line that passes through C and is perpendicular to AB. Now, we don't have a diagram. And so for me personally, this is what I would urge and encourage everybody to do. This is going to be so much easier when I can see the problem. So I know that A has coordinates minus 3, 0. So I'm going to pretend that this is minus 3, 0 here. And then B is 1, 6. So that would be forward and up a bit. So I'm going to pretend that B is here. It's not perfect. Doesn't need to be perfect. It's just giving me an idea. I can pop on my A and my B so that I've got everything I need to see. Now 5 is forward a little more. 2 is a little bit up from the A or down from the B. So I'm going to say that my C coordinate is here. That is 5, 2. It's C. And it creates a triangle, which I can show. But ultimately, they are interested in me finding the equation of the line that passes through C, passing through C, and is perpendicular to B. So we'll mark on that that is a right angle. It's a sketch. It doesn't have to be perfect, but it really helps me see what I've got available to me. So if I'm going to find the equation of this line, I'm going to need a point, which I've got. but I'm also going to need the gradient, which I do not have. On this line, A to B, I don't have a gradient, but I do have a bit more information. I've got 2 coordinates, and I can use that to help me get started with the problem, because from 2 coordinates, I can get a gradient. So that's my gradient formula. I'm going to just substitute in, and that eventually leads to 3 over 2. Now that's the gradient of AB. I want the perpendicular gradient, which is the opposite sign and the reciprocal. So I've now got the gradient of my blue line. I also know that 5, 2 lies on that line, which means that I can now use the formula y minus y1 equals mx minus x1. Now, this isn't the only way to do it, but I would really encourage this knowledge, especially if you are planning on studying your maths post-16 at A level. You are going to see this formula, and the earlier you can get familiar with it, the better. It's very simple. It's a lovely formula to use. These are your coordinates, and obviously your gradient is nice and clear with the m anyway. We're going to substitute in, and then we're going to start just simplifying what we have. So I've expanded that bracket. The -2 is going to come across and land as a +2. Obviously, I don't have a calculator to do this. So what I really need to do is write that 2 with a denominator of 3 so that I can bring it into that 10 over 3 really, really easily. That would be 6 over 3. That represents 2. So I end up with y equals -2 over 3x plus 16 over 3. When I go back up to the actual question and look at that last line, it says, give your equation in the form ax plus by equals c. So I need my x value to be on the right-hand side. And I'm also being told that my a, b, and c are integers. Now, I actually have fractions at the moment, so I need to sort that out. If I times everything through by 3, it will cancel out those fractions. It will increase the y by 3, and I will end up with -2x plus 16. I just need to bring the x this side so that it matches the form, and then I am done. So 2x plus 3y is equal to 16. And that is your final answer. Okay, so there were some fab little questions in that paper. I really hope that the practice is going well. We are dropping papers as regularly as we can. I try and make that once a week. Obviously, every now and again, work gets in the way. Recently, I've been ill and that got in the way. But where I can, I will be dropping them regularly. So good luck with your revision. Stick with us here on Target Maths, and we are here to support you all the way.